Hello students, today we're going to learn how to deal with forces drawn as vectors as part of our understanding of Newton's laws and our ability to deal with them mathematically. Remember, a quick review, a force is any push or pull. And a force is an example of a vector. A vector is any measurement that has magnitude, which is how big something is, and a direction, which tells us where we're going. The advantage of using arrows to represent these is we can use a long arrow for a large magnitude. We can show direction very easily with the point of the arrow. I strongly suggest as we're going through this, pause the video, take notes, write things down. These sample problems will help you with your assignments in class. Let's get started today. The first thing we need to know is that if we have multiple forces or multiple vectors, we can combine them. And when we combine them, we create what's called a resultant vector. The resultant is the overall end result of all of the vectors acting on an object. In the case of pushes or pulls, it would be the resultant push or pull of all of the pushes or pulls combined. When we're adding vectors, we combine them mathematically. If they're working together, we add them. If they're opposing, we subtract them. Let me show you an example. We've got a 3-unit vector to the right and a 5-unit vector to the right. If they're working together, grand total of 8 units. So I could redraw that as an 8-unit vector. Notice I'm using this little graph paper grid because it's handy for me counting. If we don't have graph paper grid, just label the number next to each arrow, the number 3 and the number 5, or the total of 8. 3 units, 5 units acting together are the same as an 8-unit vector. If they're opposing each other, well, for that one, we follow the same idea mathematically. We'll just assign one of them a negative value. In this case, it's going from right to left. It seems backwards to me, so I'm going to call that a negative. The other one seems like it's going in the positive direction. So I've got a negative 3-unit vector and a 5-unit vector. The overall resultant would be a 2-unit vector. Imagine this again in terms of pushes or pulls. If you're pushing with a strength of 5 newtons, and someone's pushing back against you with a strength of 3 newtons, the overall result is 2 newtons in your favor. So one of the challenges we have in physics is that we end up working with objects that aren't always moving just forward or backwards. Things act at an angle. Anytime we have a vector acting at an angle, we can look at the pieces that made up that angle. One piece of this is considered what we call the horizontal component. Notice this one has a run value, a horizontal value of 3. The vertical component of this can be found as well. Just count how far up the arrow travels. A lot as if we were finding the slope from our geometry classes. So the vertical component to this is 5. What I've done is I've taken this vector and I've resolved it into a horizontal component of 3 and a vertical component of 5. We need to use that because if I have multiple vectors acting at an angle, I'm going to figure out what the resultant is by adding the horizontals, adding the verticals, and using the sums to create a new vector, draw a new line for it. Let me show you how it works with this example. I have these 2 vectors that are acting on an object, and I would like to combine them, find out the resultant of these 2 that are acting against us. So first I'm going to look at the horizontal. My first arrow has a horizontal component of 4. My second arrow has a horizontal component of 5. The resultant of that is a horizontal component of 9. There's my 4, and there's my 5. That's where those numbers came from. If I add them together, we get the 9. We'll do the same thing for the vertical. The vertical component is 4 for the first arrow. For the second arrow, you notice it's moving downward. I'm going to give that a negative 3. So my vertical component total is 1. I can use these to draw a resultant. My resultant will be a combination of those 2. I'll go over 9 and up 1 and draw the line. If I were to separate that part out and take a look at just that piece, you can see I went over 9 and up 1. This also gives us a little right triangle, and we can use that right triangle to figure out the magnitude of that resultant vector. I'll just use the Pythagorean theorem. Looks like Google presentation doesn't like my square root symbol. That's a square root. One side is 9, the other side is 1. That's my a and b. And if I'm solving for c, and the a squared plus b squared equals c squared, it works out to be the square root of 9 squared plus 1 squared. So my value is 9.06 units. And that's the length of my resultant vector. That's its magnitude. We can also find the angle of that, which gives us the direction part with a high degree of accuracy. All we have to do is use our SOHCAHTOA work from our last unit that we reviewed. In this case, I'm going to choose tangent. The tangent of that angle theta is the opposite side over the adjacent side. Those are the two that I know best. So I'll set up my formula. Tangent of theta is 1 over 9. And solve for theta, 6.34 degrees. Again, Google presentation doesn't like those symbols. Figure that out later. Let's look at another example. What is the length and angle of the resultant vector? If you're feeling tough, pause it, try it out, and then we'll come back together and look at the solution. So first I find the horizontal. The first one has a horizontal of 4, the second has a horizontal of 2. So my total horizontal is 6. The next step is to find the vertical. My first one goes up 2, the second one goes downward 5, so negative 5, for an overall vertical resultant of negative 3. Next, I'll draw the resultant arrow from this. Over 6, and down 3, and I get my new resultant arrow. This is the resultant vector. Notice with the dotted lines and the yellow line, I made a little right triangle. I can find the direction of this. Again, using the Pythagorean theorem, we find the magnitude, and using SOHCAHTOA, we find the angle. Now notice this is the angle downward from horizontal, negative 26.5 degrees. Usually when we're finding those angles, we're going to find that angle from horizontal. What if you have 3 or more vectors? Well, you solve it the same way. It looks more complicated because there's more lines on the paper. The process is the same. We'll add up all the horizontals. My first arrow goes left 1, my second arrow goes right 4, and the third arrow goes right 3. An overall horizontal movement of 6. Then we add the verticals. The first one has a vertical of 2. The second one also moves upward 2. The third one doesn't move upward at all. So my total vertical is 4. Then I'm going to draw a new resultant. Go over 6, up 4, draw my arrow. Now, we can also combine these graphically. This is how we find that resultant mathematically, but I can also combine those arrows and figure out what my resultant would be without some math. Here's how we do it. I'm going to take each one of these vectors and I'm going to slide them around on the grid. As long as I don't change the angle, or the vertical, or the horizontal component to the arrow, it doesn't matter where on the grid I draw it. So I'm going to draw one of those arrows right here. That's the arrow that goes over 4 and up 2. Then I'm going to draw the next arrow. I chose the one that goes horizontally, over 3 and up 0. Now I'm going to draw my third arrow, again connecting the tip of one to the tail of the next. And you'll notice it ends right when my yellow arrow ends, and it starts right when my yellow arrow starts. We can graphically find any resultant vector this way, and then work our way backwards to get that triangle. And it'll give us the same resultant as if we would have just calculated mathematically. So, your mission, try to apply these skills on our assignment today.